Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on surface area and finding the surface area of prisms. If you need any extra help in finding the surface area of prisms, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 312, there's a dedicated video tutorial there on finding the surface area of prisms. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number 1. So question number 1 says, shown below is a cube with a side length of 4 centimeters. So we've got this cube with a side length of 4 centimeters, and we've been asked to find the total surface area of this cube and to include suitable units. So to find the surface area of a cube, we need to find the area of all 6 faces. So we're going to find the area of the front, the back, the left-hand side, the right-hand side, the top and the bottom. And what's great about a cube is all of those squares are identical. All of those faces are squares and they're 4 by 4 squares. So let's find the area of the front of this cube. So to find the area of the front of this cube, the area of this face, we're going to do the length times the width. So we're going to do 4 times 4. And 4 times 4 is equal to 16. So that means the area of the front of this cube is 16 centimeters squared. That means the area of all 6 faces is 16 centimeters squared. The front will be 16 centimeters squared, the back will be 16 centimeters squared, the left-hand side will be 16 centimeters squared, the right-hand side will be 16 centimeters squared, the top will be 16 centimeters squared, and the bottom will be 16 centimeters squared. So you just need to add up 6 16s, or you could just do 16 multiplied by 6, and that's equal to 96 centimeters squared. And that's it. That's the total surface area of that cube. Okay, let's look at our next question, question number 2. So question number 2, we've been asked to work out the surface area of this cuboid. So we're going to need to find the area of the front, the back, the left-hand side, the right-hand side, the top and the bottom, and then add them all up. So let's start off with the front. The front is a rectangle. They're all rectangles, all the faces, and it's got a length of 10 centimeters and a width of 3 centimeters. Because the height of the cuboid is 3 centimeters, this length is 3 centimeters, that means that this length would be 3 centimeters. And 10 times 3, so for the front, 10 times 3 would be equal to 30 centimeters squared. And if the front is 30 centimeters squared, that means the back will also be 30 centimeters squared. So 30 centimeters squared. So that's the front and the back. Now let's check out the right-hand side. The right-hand side, it's another rectangle. It's got a length of 5 centimeters and a width of 3 centimeters. So we're going to do 5 times 3. So for the right-hand side, 5 times 3 is equal to 15 centimeters squared. So that's the area of this right face of the cuboid. And the left-hand side will have the same area. So that means for the left side, it'll also have an area of 15 centimeters squared. So that's fantastic. We've now done the front, the back, the right-hand side and the left-hand side. We just now need to do the top and the bottom. So if we have a look at the bottom here, it's a rectangle again. It's got a length of 10 centimeters and a width of 5 centimeters. And 10 times 5 is equal to 50. So that's 50 centimeters squared. So that means the area of the bottom, so for the bottom of that cuboid, the area would be 5 times 10, which is equal to 50 centimeters squared. And if the area of the bottom is 50 centimeters squared, the area of the top of the cuboid will also be 50 centimeters squared. So that'll be 50 centimeters squared as well. So if we want to find the total surface area of this cuboid, we just need to do 30 plus 30 plus 15 plus 15 plus 50 plus 50. Just add up those 6 areas. So the area of all 6 faces. So let's do that. And it's a non-calculator question. So 50 plus 50 is 100. Plus 15 is 115, plus another 15 is 130, plus another 30 is 160, plus another 30 is 190. That'll be 190 centimeters squared. And that's it. That's the total surface area of that cuboid. Okay, let's look at our next question, question number 3. So question number 3, we've been shown this triangular prism. So we've got this triangular prism, and we've been asked to work out the surface area of this prism. So we want to find the total surface area of this prism. Okay, so let's consider the faces of this triangular prism. So this triangular prism, it's got 5 faces. It's got the triangular front, the triangle at the back, and those 2 faces will have the same area. We've got the rectangle at the bottom. We've got this rectangle, this slanted rectangle here, and on the left-hand side, we've also got another rectangle. So there's 5 faces, and we need to find the area of each of them. So let's consider the front to begin with. So the front is a triangle, and we've got this triangle here. And to get the area of a triangle, we do half the base times the height. So we're going to do 4 times 3 is 12, and then half it is 6. So that'll be 6 centimeters squared. So 6 centimeters squared, because we've done a half of 3 times 4. And 3 times 4 is equal to 12, so it's a half of 12, and a half of 12 is equal to 6. Or you could, if you wanted to, half the 4 first, which is 2, and then times by 3 to get 6. So as long as you half, either you times them and then half it, or half one of them and then times them. So the area of the front of this triangular prism is 6 centimeters squared. So that means the back will also have an area of 6 centimeters squared as well. So that's the front and the back. So they've got areas of 6 centimeters squared each. Now let's consider the bottom. So the bottom is a rectangle. It's got a length of 10 centimeters and a width of 4 centimeters. So the bottom, or the base, of this triangular prism, we're going to do 10 times 4, and 10 times 4 is equal to 40. So the area of the bottom, or the base of this triangular prism, is 40 centimeters squared. Okay, so we found the area of 3 of the faces. Now we just need to do this slanted face here, and we also need to do the area of the left-hand face. So let's have a look at the left-hand face. So the left-hand face is a rectangle as well. I'm just going to do a little sketch for there. So that's the rectangle. It's got a width of 3 centimeters, and the length of it, that 5 is the diagonal here. We need to make sure we're getting the right length here. Here we've got the length of the prism being 10 centimeters. That means that this length is 10 centimeters. So that means that this rectangle has got a width of 3 centimeters and a length of 10 centimeters. And 10 times 3 is equal to 30. So that means the area of this rectangle on the left hand side would be 30 centimeters squared. So that's fantastic. We've now got the area of 4 of the faces. We're left with just one more, just this right hand face, this slanted face here, this one here. And to find the area of this face, again, it's just a rectangle, and we're going to do 10 times 5. And 10 times 5 is equal to 50. So that means the area of this face, this right hand face, or this slanted face, is equal to 50 centimeters squared. Now we've been asked to find the total surface area, so we just need to add these up. 50 plus 30 is 80, plus 40 is 120, plus 6 is 126, plus 6 is 132 centimeters squared. And that's the total surface area of that triangular prism. And that's it. Okay, let's have a look at the next question, question number 4. So question number 4, we've got this triangular prism, and we've been asked to find the total surface area of this triangular prism. So to find the total surface area of this triangular prism, we need to find the area of the 5 faces. The triangle at the front, the triangle at the back, the rectangle on the base, the rectangle on the left-hand face, and that slanted rectangle on the right-hand face. And if we find the area of those 5 faces, we can add them up to get the total surface area. Okay, so let's start off with the front. So for the front, we've got this triangle. And to find the area of a triangle is equal to half the base times the height. So if we do half the base times the height, we'll get the area of that triangle. And that will be equal to half of the base, which is 15, times the height, which is equal to 8. So we do 15 times 8, and then we half it. 15 times 8 is equal to 120, and half that is equal to 60 centimeters squared. That's a calculator question, so you can just type that into your calculator. And also just to remember that you can times them together and then half it, or you could half one of them and then times it. So you could do 7.5 times 8, or you could do 4 times 15, and that's all equal to 60 centimeters squared. So that means the area of the front is equal to 60 centimeters squared. Now we need to do the back. Well, the back's the same as the front, so the back will have an area of 60 centimeters squared as well. So that's 2 of the 5 faces. Now let's have a look at the base. And that base is a rectangle. If you have a triangular prism, the base of it will be a rectangle. And in terms of that rectangle, it's got a width of 15 centimeters and a length of 20 centimeters. So if we do 15 times 20, and it's a calculator question, so you could type that into your calculator if you wanted to, and 15 times 20 is equal to 300. So that means the area of the base is equal to 300 centimeters squared. So that's the area of the base. Now let's do the area of the left-hand face. So in terms of the left-hand face, we've got this rectangle here. And with that rectangle, it's got a width of 8 centimeters, and the length of it will be how long, or the depth of the prism, which is 20 centimeters. So you get 8 times 20, and 8 times 20 is equal to 160 centimeters squared. So that means the area of the left-hand face is 160 centimeters squared. So that's fantastic. That's the area of the left-hand face. And now we just need to find the area of the right-hand face. So in terms of the right-hand face, that slanted face, this face here. Again, it's another rectangle. It's got a length of 20 centimeters and a width of 17 centimeters. So we do 17 times 20, that's equal to 340. So that means the area of that rectangle, the right-hand face, will be equal to 340 centimeters squared. And that's fantastic. We can now add these up to get the total surface area. And when we do 60 plus 300 plus 160 plus 340, that's equal to 920 centimeters squared. So that's the total surface area, 920 centimeters squared. Okay, let's look at our next question, question number 5. Okay, so question number 5. Question number 5, we've been given this prism. So we've got this parallelogram prism. It's a prism that has a cross-section of a parallelogram. And we've been asked to find the total surface area of this prism. So if we want to find the total surface area of this prism, we need to find the area of the 6 faces. We need to find the area of the front, that's the parallelogram. That'll be the same as the back, and the back's the second face. We need to find the area of that right-hand face. We need to find the area of the left-hand face, and again, they'll be the same as each other. And we need to find the area for the top of the parallelogram and the bottom of the parallelogram. So let's do that. Okay, so let's start off with the front. So the front of this prism is a parallelogram, and to find the area for parallelogram, you do the base times the height. And the base of the parallelogram will have a length of 10 centimeters because the length at the top of it is 10 centimeters. And the height is the distance between the two parallel sides, so that's 5 centimeters. Ignore the 6 at this stage, the 6 is the length of the diagonal. We'll need that to find the area of the left-hand face and the right-hand face, but in terms of the front, we're just going to do the base times the height. And the base is equal to 10, the height, the distance between the two parallel sides, is 5, and 10 times 5 is equal to 50 centimeters squared. So that's the area of the front of this prism. And the back will have the same area, so the back will also have an area of 50 centimeters squared. So that's fantastic. So we've done the front and the back. Okay, now we need to find the area of the left-hand side and the right-hand side. Let's have a look at this right-hand side here. So the right-hand side here, it's a rectangle. The length of the rectangle is 20 centimeters, and the width of the rectangle is 6 centimeters. This length is 6, so this length is 6. So if we do 20 times 6, so if we do 20 times 6, that's equal to 120 centimeters squared. So the area of this rectangle on the right-hand side of this parallelogram prism is equal to 120 centimeters squared. In terms of the left-hand side will have the same area, so the left-hand face will have an area of 120 centimeters squared as well. So we've done the front and the back, the left-hand side and the right-hand side. Now we just need to do the top and the bottom. And again, they're going to be rectangles, and they're going to have the same areas. The width of each of those rectangles will be 10 centimeters, and the length of them will be 20 centimeters. And 10 times 20 is equal to 200. 10 times 20 is equal to 200 centimeters squared. So the top will have an area of 200 centimeters squared, and the bottom will also have an area of 200 centimeters squared. So that's fantastic. We've now got the area of the 6 faces. We've got the front and the back, each with an area of 50 centimeters squared. The left-hand face and the right-hand face, each with areas of 120 centimeters squared. And the top and the bottom, each with areas of 200 centimeters squared. So let's add them together to get the total surface area. So 200 plus 200 plus 120 plus 120 plus 50 plus 50. Okay, so 0 plus 0 plus 0 is 0. 2 plus 2 is 4. Plus 5 is 9, plus 5 is 14, put a 4 down and carry a 1. 2 plus 2 is 4, plus 1 is 5, plus 1 is 6, plus another 1 is 7. So the total surface area of this prism is 740 centimeters squared, and that's it, 740 centimeters squared. Okay, let's look at our next question. Okay, question number 6. Question number 6, we've got this L-shaped prism, and we've been asked to find the total surface area of this prism. So to find the total surface area of this prism, we need to get the area of the front, this L shape at the front, the L shape at the back. Then we need to find the area of this rectangle, this rectangle, this rectangle, this rectangle, that rectangle, the left-hand face, and the bottom. So actually, I'm going to label these A, B, C, D, and so on. So I'm going to call the front of it A. I'm going to call the back of it B. I'm going to call this face C. I'm going to call this face D. I'm going to call this face E. I'm going to call the top of it F there. I'm going to call the left-hand face G, and I'm going to call the base of it H. So I've just labelled each of the faces A to H, and now we're going to find the area of each of those and then add them all up. Okay, so let's start off with A. So A, actually I'm just going to move the A a second. Okay, so if we want to find the area of A, I'm just going to write front there. So if we want to find the area of A, what we would do is we'd split it up into 2 rectangles. So I'm just going to chop it down this way. And in terms of this rectangle, we know it's got a height of 16 centimeters and a width of 4 centimeters. So if we do 16 times 4, that's equal to 64 centimeters squared. So that's the area of this rectangle. In terms of this rectangle here, it's got a length of 12 centimeters and a width of 7 centimeters. And 12 times 7 is equal to 84 centimeters squared. So it means the total area of A, the front of it, would be 64 plus 84, which is equal to 148 centimeters squared. So that's the area of the front, and the area of the back will also be 148 centimeters squared. Okay, now let's have a look at the other faces. Okay, now let's have a look at C. So in terms of C, it's a rectangle with a width of 5 and a height of 7. And 7 times 5 is equal to 35 centimeters squared. Actually, I'm just going to write these in a list here. The A has an area of 148. B has an area of 148. C has an area of 35 centimeters squared. So we've got the area of 3 faces so far. D, well again, D is a rectangle. The length of the rectangle is 12, the width of it is 5, and 12 times 5 is equal to 60. So the area of D is 60 centimeters squared. So D, 60 centimeters squared. E, let's have a look at E now. So if we go up, E is another rectangle. The height of E, well actually the height of E is not actually labelled here. So with the height of the whole prism is 16 centimeters. This height is 7. So if we do 16 take away 7, that's equal to 9. So that means the height of E is 9. The width of E is equal to, this rectangle would be equal to 5, and 9 times 5 is equal to 45. So that's 45 centimeters squared. So the area of E, that rectangle, is 45 centimeters squared. Okay, now let's go up to the top. The top will be 4 times 5, because this length is 5 and this length is 4, and 4 times 5 is equal to 20. So in terms of F, the area of F is 20 centimeters squared. Okay, now we're just left with two faces, G and H. G, this left-hand face, is got a height of 16 and a width of 5. So if we do 16 times 5, that's equal to 80. So that means the area of G is 80 centimeters squared. So G, the area is 80 centimeters squared. And then that means we're left with H. So if we go here to H, the base of it, the base of the prism, it's got a width of 5. We need to find its length here, the length of the base. And to do that, we'll do 4 plus 12. And 4 plus 12 is 16. So that means that the length of the base is 16 centimeters. So we're going to do 16 times 5. And 16 times 5, we've done that already, is equal to 80. So that means the area of the base of this prism is 80 centimeters squared. So that's fantastic. We now know the area of all 8 faces. We now just need to add them up to get the total surface area. So let's add them up and see what we get. And when we add up all those faces, we get a total surface area of 616 centimeters squared. So 616 centimeters squared. And that's it. Okay, let's look at our next question, question number 7. So question number 7, we've got this prism. It's a trapezoid prism. We've got a trapezium being the cross section. We've got a trapezium as the cross section. And as you can see, it's a prism because each of the cross sections are the same. And we've been asked to work out the total surface area of this prism. So that means we need to get the area of all 6 faces: the front, the back, the right-hand face, the top, the left-hand face, and the bottom. Okay, so let's start off with the front and the back. So in terms of the front, it's a trapezium. So the area for trapezium is equal to a half A plus B multiplied by H, where A and B are the length of the 2 parallel sides and H is the distance between them. So in terms of the lengths of the 2 parallel sides, A is going to be equal to 12, that's one of the parallel sides, and B, the other parallel side, would be this side here. And if this side's got a length of 8 centimeters, that means that this length's got a length of 8 centimeters. So that means that B is equal to 8. And H is the distance between them, so that perpendicular distance between the lines, which is equal to 3 centimeters. Actually, if you turn your head or rotate your head sideways, you can actually see it more clearly as a trapezium, where you've got the 2 parallel sides, the height of it, and so on. The 5 here, we're not going to use 5 as the height of the trapezium because that's a diagonal length, but we will need that later on in the question. Okay, so let's substitute in these values. So the area of the front of this prism, so the area of this trapezium, will be equal to a half A plus B, so it's going to be 12 plus 8, and then times by H, the distance between them, which is 3. So it's a calculator question. You can just type this into your calculator. You're going to get an answer of 30 centimeters squared. And just to explain why that's the case, 12 plus 8 is equal to 20. Half of that is 10, and times 3 is 30. So the area of the front of this prism is 30 centimeters squared. The area of that trapezium is 30 centimeters squared. And the back will have the same area. The back will also have an area of 30 centimeters squared. Okay, so we've done the front and the back of this prism. Okay, now let's have a look at the right-hand side. So the right-hand side, it's a rectangle, and it's got a length of 10 centimeters and a width of 8 centimeters. So 10 times 8 is equal to 80 centimeters squared. Now in this case, the area of the right-hand side of the prism won't be the same as the area of the left-hand side of the prism because obviously the heights of those two rectangles are different. Okay, now, so we've done the right-hand side. Now let's deal with the top. The top will be, it's a rectangle again. The width of it is 5, so I did say we would be using that 5. The length of it is 10, because if that length's 10, that length's 10. So we're going to do 5 times 10 is equal to 50 centimeters squared. So we've done the front, the back, the right-hand side, and the top. Now let's deal with the left-hand side of that prism. So it's going to be a rectangle. It's going to have a height of 12 and a width of 10. So 12 times 10, so for the left-hand side, we're going to do 12, the height of that rectangle, times the length of the rectangle, which is 10. And 12 times 10 is equal to 120 centimeters squared. So we've now done the left-hand face, and now we're just left with the base. And the area of the base will be equal to 3 times 10, because it's a rectangle, and the length of it is 10, the width of it is 3, and 10 times 3 is equal to 30 centimeters squared. So that's fantastic. We've got the area of the front, which is 30 centimeters squared, the back, 30 centimeters squared, the right-hand face, 80 centimeters squared, the top, 50 centimeters squared, the left-hand face, 120 centimeters squared, and the base, 30 centimeters squared. And if we want to find the total surface area of that prism, we need to add together those 6 areas. So let's do that. And when we do 30 plus 30 plus 80 plus 50 plus 120 plus 30, we get an answer of 340 centimeters squared. So that's the total surface area of that prism, 340 centimeters squared. Okay, let's look at our next question, question number 8. So question number 8 says, show and below is a prism, and we're told the cross-section of the prism is a trapezium A, B, C, D. And we've got some measurements there. We've got the AB is equal to 5, BC is equal to 3, CD is equal to 5 centimeters, AD is equal to 9 centimeters. The perpendicular height of the trapezium, so the distance between the two parallel sides of the trapezium, is equal to 4 centimeters, and the length or the depth of the prism is equal to 9 centimeters. And then we've been asked to work out the total surface area of the prism. So we want to find the total surface area of this prism. So we need to find the area of the trapezium at the front, the trapezium at the back, which will have the same area, the area of the top, the area of the right-hand face, the left-hand face, and the base. So let's start off with the front, so that trapezium. So the area for trapezium, the area is equal to half A plus B times H, where A and B are the two parallel sides and H is the distance between them. So we've got a half of A plus B, so that's the length of the two parallel sides. That'll be 3 centimeters and 9 centimeters. So that's going to be 3 plus 9. And then we're going to times that by H, the distance between them, the perpendicular distance between them. So that's this distance here of 4. Okay, so to find the area of that trapezium, we just need to type this into our calculator. And when we do that, we get an answer of 24 centimeters squared. So that's the area of the front. The back will have the same area as well. So the area of the back will also be 24 centimeters squared. Now let's have a look at the right hand side. The right hand side, it's a rectangle and it's got a length of 9 and a width of 5, and 9 times 5 is equal to 45 centimeters squared. The area of the left hand face, it's also a rectangle. It's got a width of 5 centimeters and a length of 9 as well. So it's going to be 9 times 5, which is 45 centimeters squared as well. So that's fantastic. We've now got the area for the faces. Now we just need to do the top and the bottom. So in terms of the top, that's going to be, well, the width of that rectangle is 3. The length of it is 9. So 3 times 9 is equal to 27 centimeters squared. And finally, we've got the base. And in terms of the base of this prism, it's a rectangle, that's actually a square. It's 9 centimeters by 9 centimeters. So 9 times 9 is equal to 81 centimeters squared. So that's fantastic. We've got the area of 6 faces. Now we just need to add them up. So we're going to do 24 plus 24 plus 45 plus 45 plus 27 plus 81. And let's see what we get. And when we do that, we get an area of 246 centimeters squared. And that's it. That's the total surface area of that prism. Okay, let's have a look at our next question, question number 9. So question number 9 says, Brad creates an ornament by joining 2 cubes as shown. So he's got these 2 cubes and he's joined them. And we've been asked to work out the total surface area of the ornament. So we want to find the total surface area of this ornament. So we want to find the area of all the faces. So in terms of the faces, let's focus on this cube on the left hand side. It would have its front, its back, its left hand face, its top and its bottom. They're all 4 by 4 squares. We can find the area of those quite easily. In terms of the cube on the right hand side, we'd have the front, the back, the right hand side, the base and the top, and we can find the area of those 5 squares quite easily as well, because they're all 3 by 3 squares, and we can find the area of those 5 squares quite easily. And then the 2 shapes are joined together, the 2 cubes are joined together, so we're left with this face here, and we'll be left with this face here, and we need to find the area of this face. Now in terms of this face, well, if they weren't joined up, this face here would be a 4 by 4 square. But a 3 by 3 square has joined itself onto it, has been attached onto it. So what's left to be the difference between them? So if we find the area of the whole square, which would be 4 times 4, which is 16, and then take away 3 times 3, which is 9, what's left would be that area there, because 9 centimeters squared off that face is covered up, it's joined up, so it's not on the surface anymore, but what's left will be the difference between them. Okay, so let's start off with this larger cube, and let's look at the face at the front of this cube. It's a 4 by 4 square, and 4 times 4 is equal to 16 centimeters squared. So that means the area of the front of this cube is 16 centimeters squared, the back would be 16 centimeters squared, the top would be 16 centimeters squared, the left hand face would be 16 centimeters squared, and the base would be 16 centimeters squared. So we would have 5 complete faces. So let's take the 16 centimeters squared and times that by 5, and that's equal to 80 centimeters squared. So that means that the area of all the faces of this cube, except for this part here, is equal to 80 centimeters squared. Okay, now let's look at the smaller one. So let's consider the face at the front of the smaller cube. It's a 3 by 3 square, and 3 times 3 is equal to 9. So 3 times 3 is equal to 9 centimeters squared. So that means the area of the front of this cube would be 9 centimeters squared. The back of the cube would be 9 centimeters squared. The right hand face of the cube would be 9 centimeters squared. The base of the cube would be 9 centimeters squared. And the top of the cube would be 9 centimeters squared. So that means that there's 5 complete faces of this cube on the surface of this ornament. So if we do 9 times 5, that's equal to 45 centimeters squared. So we've now found the area of all the faces of this ornament except for this shaded part here. This shaded part here is on the surface of the ornament, so we need to find the area of this shaded part here. And I'm just going to change colour of ink here to blue. So we want to find the area of this shaded part here. And then once we find the area of the shaded region here, we can then add it to 80 and to 45, and that'll be the total surface area of that ornament. So to find the area of this shaded region here, what we're going to do is we're going to consider the whole face. And we know the area of the whole face, this whole right hand side of this cube, would be 16 centimeters squared. But it's not a complete face because another cube's been joined onto it. And where the two cubes join is now inside of the shape, so not on the surface. So if we consider that left-hand face of this smaller cube, that's got an area of 9 centimeters squared. So that means that 9 centimeters squared of this face has been covered up. So if we take away 9, that's equal to 7, because 16 take away 9 is equal to 7. So that means that this shaded region here would have an area of 7 centimeters squared, because that's how much is left whenever that 9 centimeters squared is covered up of that 16 centimeters squared. So that's fantastic. We now know the area of the 5 faces of this cube that aren't joined up. So the area of those 5 faces would be 80 centimeters squared. We know the area of the 5 faces of this cube that aren't joined up is equal to 45 centimeters squared. And then we know that this shaded region has an area of 7 centimeters squared. And then if we add them up, that'd be the total surface area of the ornament. So we just need to do 80 plus 45 plus 7. And when we do that, we get the total surface area of that ornament. So let's do that. 0 plus 5 is 5 plus 7 is equal to 12. So to put a 2 down and carry a 1. And 8 plus 4 is equal to 12 plus 1 is equal to 13. So it means the total surface area of that ornament is 132 centimeters squared. And that's it. Okay, let's have a look at our last question, question number 10. So question number 10 says, shown below is a prism. So we've got this prism, it's a triangular prism, and we're told the cross section of the prism is a right angle triangle. And as you can see, it is a right angle triangle. And we've been asked to work out the total surface area of this prism. So if we want to find the total surface area for this prism, we need to find the area of the front, which is the triangle, the area of the back, which is the triangle as well, and they'll have the same area, the area of the base, the area of the left-hand face, and the area of the right-hand face. And that right-hand face is that slanted face there. So we need to find the area of the 5 faces, and then we're going to add them all up to get the total surface area. Now this is the last question for a reason, because in this question we're going to need to use a thing called Pythagoras' theorem. And if you know Pythagoras' theorem, fantastic, you should be able to do this question. If you haven't yet learned Pythagoras' theorem, it could be useful to watch video number 257 on Corbettmaths. Video number 257 on Corbettmaths is the video on Pythagoras' theorem, and it explains how we can use Pythagoras' theorem to use, if we've got the 2 shorter sides of a right angle triangle, how we can use Pythagoras' theorem to find the length of that longest side, the length of the hypotenuse here. And that's what we actually need to do in this question. We need to find this length here. Okay, so if you need a bit of a recap on Pythagoras' theorem, watch video number 257 on Corbettmaths now. It'd be a really useful one for you to watch. Okay, so let's find the total surface area for this prism. So let's start off with the front. The front is a triangle, so the area for a triangle is equal to half the base times the height. So we're going to do the base times the height and then divide it by 2. So we're going to do a half of 24 times 7. And when we do that, let's see what we get. And when we do a half of 24 times 7, or type that into our calculator, we get an answer of 84 centimeters squared. So that's the area of the front of this triangular prism. And it'll be the same as the back, so that's the front and the back. So the front, let's go down here. The front will have an area of 84 centimeters squared. The back will have an area of 84 centimeters squared. Okay, so that's 2 of the faces. Now let's deal with the base. It's quite straightforward as well. It's a rectangle. It's a 7 by 30 rectangle. The width of it is 7 centimeters and the length of it is 30 centimeters. So if we do 7 times 30, that's equal to 210 centimeters squared. So that's the area of the base of this triangular prism. So the base has an area of 210 centimeters squared. Okay, next, the left-hand face. So the left-hand face there, it's a rectangle as well. So this left-hand face. And this left-hand face is a rectangle. The length of the rectangle is 30 centimeters. That's 30 centimeters there, the length of it. The height of it is 24. And if we do 30 times 24, that'll be the area of that left-hand face of that triangular prism. So 30 times 24 is equal to 720 centimeters squared. So that's the area of that left-hand face. So the left-hand face is equal to, the area is equal to 720 centimeters squared. Okay, so that's fantastic. We've now found the area of 4 of the faces, but we've just got one more face we need to find the area of. Now I've kept the best to last here because there's a bit of maths we need to do to be able to find the area of this rectangle. So we want to find the area of this right hand face, this slanted face here. And it's a rectangle. As you can see, the length of it is 30 centimeters, but we don't actually know the width of that rectangle. We need to do 30 times something. So we need to use a thing called Pythagoras' theorem to find this length. And I'm just going to call this length x to begin with, okay? It's what we call the hypotenuse. It's the longest side of a right angle triangle. It's the side opposite that right angle. So to use Pythagoras' theorem, we write down Pythagoras' theorem, which is a squared plus b squared equals c squared, where a and b are the two shorter sides of the right angle triangle, and c is the longest side, the hypotenuse. So a and b, they're the two shorter sides. So let's call 7a and 24b, and let's substitute those into Pythagoras' theorem. So a squared, that's going to be 7 squared, plus b squared, that's going to be 24 squared, is equal to c squared. And we've called that x, so we're just going to call that x squared. 7 squared plus 24 squared is a calculator question, so you can just do in your calculator 7 squared, which is 49, plus 24 squared, and you'll get an answer of 625, and that's equal to x squared. So it means that x squared is equal to 625. Now this length here clearly isn't 625, that's this length squared. So to find what x is, we just need to square root 625. So x is equal to the square root of 625, and the square root of 625 is equal to 25. So that means that x, this length, is equal to 25 centimeters. So x is 25 centimeters. So that's fantastic. We now know the length of this rectangle and the width of the rectangle. So we can now do 30 times 25 to get the area of that rectangle, which is equal to 750 centimeters squared. So that's fantastic. So the area of the right hand face is equal to 750 centimeters squared. So if we want to find the total surface area of that prism, we just need to add together the area of the front, which is 84 centimeters squared, the area of the back, which is 84 centimeters squared, the area of the base, which is 210 centimeters squared, the area of the left-hand face, which is 720 centimeters squared, and finally the area of this right-hand face, which is 750 centimeters squared. And when we do that, we get an answer of 1,848 centimeters squared. So that's the total surface area of that prism. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on surface area. If you need any extra help on finding the surface area of prisms, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 312, there's a dedicated video tutorial there on finding the surface area of prisms. Alternatively, you can scan this QR code. But in this video, we went through the video solutions to the practice questions. I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone who might find the Corbettmaths resources useful, please share them. If you know a friend who maybe needs some help with their maths, please tell them about Corbettmaths. If your teacher might find the resources useful, tell them about Corbettmaths as well, and that'd be fantastic. So thank you. Cheers. Bye.